The main goal for this is content-based recommendation and creating both an item profile, which consists of featured value pairs, and also a user profile, which summarizes the preferences of the user, which is based off the row utility metrics. And we also try to generalize the vector approach, which is doable for features that are sets of discrete values. An example being if a feature in movies is a set of actors and like there's a component for each actor. It's like a 1 and 0, like a binary thing, and you can do that for the directors and everything else. And like another class of features, which is not easily represented by the Boolean vectors and numerical features. And I have an example here where like if the only feature in movies is like a set of actors and the average rating, and if you have like 2 movies with like 5 actors in each, and 2 of the actors are in both movies, then like one movie can have an average rating of 3 and the other average of 4. The vector would look similar to that down there, but in theory there's like an infinite number of these all. Next slide. And then for user profiles, like we not only need to like also create vectors describing the items, but we also need vectors with the same components to describe the user's preferences. And for that, like we could use the utility matrix, which represents a connection between the users and items. And then like there's several examples which here demonstrate that. Items in movies represent Boolean values, like 20% of them that have the user like Julia Roberts. Then like the component will be 0.2 for Julia Roberts, and there's also other like different like I guess variations and everything. Right. And so when you're recommending items to users based on content, with profile vectors for both users and items, like you can estimate the degree to which a user would prefer an item by computing the cosine distance between the user and items vectors. Like, and another example is, it takes the example of 9.3 where it's like user row components for actors proportional to the likelihood of actors appear in the movie. So the highest recommendations, which is the lowest cosine distance, belongs to the movies with lots of actors which the user likes. And as long as the actors and information we have, like that's probably the best that can be done. And for 9.4, there's also another example like with a bit more values, and again using the cosine value.
What is 9.4? Is that a figure you have in your PowerPoints, or?
No, it was just mainly like an example that was just given. So, and that's what was pretty much.
You mean in the book, or?
Yeah, in the book. In section. Yeah, in the section. And then like finally, there's the classification algorithms, which it's another approach to recommending systems, which uses item profiles and utility matrices to treat the problem as more machine learning. And you can regard the data as a training set, and for each user you build a classifier which will predict the ratings. So one thing you use for that is a decision tree, which is a collection of nodes arranged as a binary tree. And what it is like the leaves of the tree, they can render decisions, and each of the interior nodes, they're conditioned on the object being classified. And so you basically first start at like the root of the tree, where you classify the item and apply the predicate at the root of it. And if it's true, then you go to the left child, and if it's false, you go to the right one, and you repeat it for each node until like you reach like an actual like leaf. And what that leaf will do is classify the items whether it's liked or not. And building this tree, it requires like a predicate for each interior node, and there's several ways to pick the best predicate, but they all have to like try and arrange it so that like one of like the child nodes or whatever gets most of the positive examples, and another child gets a negative example, so that it's more balanced. So my question is, what is a decision tree? Yeah.
Collection of nodes arranged as a binary tree.
Indeed.
Alright, so the next section was collaborative filtering, and